I'm going to take one look at a case study, and this is virtualized DAS in the cloud. So we'll take those three. I'm going to use just one, which is the SaaS solution, in order to address cloud requirements. So first of all, what's the cloud? Well, we all live in the cloud. We all use the cloud. When I get on my iPhone, I jump on the cloud and do some work and jump back off the cloud. Typically, it's shared services. It's under virtualized management. So again, you've got centralized, virtualized management across all of your resources. It's accessible over the internet, both to users and to businesses. So the cloud makes a lot of sense in order for businesses to transact. Examples would be software as a service, platform, so I'll get into a little bit of examples of these, platform as a service, and infrastructure as a service. All of these are driving new DAS requirements. It's if you want to put it in perspective, it's like the rebirth of DAS. It's for years and years and years with network-attached storage, storage over IP, SAN, NAS. It's been the death of DAS. But this is the resurgence of DAS because the cloud is driving such economies of scale and such need for easy bricks to be deployed in order to solve their compute and storage requirements. Examples would be Salesforce.com. This is a great example of software as a service, where you don't need to have any infrastructure. You just log on and do all of your business through Salesforce. Google would be a hybrid where they're platform as a service. There's the Google app platform. They're also software as a service with a lot of their services. Amazon is really the big gorilla here with their AWS and their ability to perform and provide services, vast amounts of services in storage and in compute power for their customers. Rackspace is a great example of infrastructure as a service, where you got your own software and you don't want to have to deal with all the cost of IT, so you use a company like The Planet or Rackspace. And Verizon, again, is a platform as a service. The requirements are scalability. You need to be able to scale this efficiently. You need to be green, so power, space, and cooling is very important to the cloud. Due to the sheer scale, customers are very extremely cost sensitive, so this is a great area for open systems in order to address problems in the cloud. They don't want proprietary systems, they want open systems because it's very scalable, it's very manageable, it's got a lot of innovation in it. Centralized management is very important. You can't have different pools or islands of storage or compute power that you have to manage. And availability, it can never go down. You do not want the cloud to go down because you don't affect just your own local enterprise. You affect everybody globally that's using services on the cloud. So availability has to be very high. So we're not talking 5 nines anymore. You want to go beyond 5 nines. So how to scale? Well, the cloud is solving that by just adding servers. So you just add servers or bricks. Think of them as bricks of storage. So you could solve a lot of your problems by just adding more bricks. And that could be efficient bricks where storage is very efficient, or it could be more compute power. The cost is about half that of a SAN. So it's very cost effective, cost efficient. You've got group management capabilities like you do with typical storage fabrics. And the availability is SAN-like. You can get different levels of availability depending on how much you want to invest in that middleware layer. So how redundant, how, do you have a remote replication? Is it failover at the node? Do you have failover down at the storage as well? There's many different ways to reach these requirements. A cost example would be a typical SAN, where you've got dual redundancy at the controller level. You've got storage, and I've kept the storage the same across both sides here. So your subtotal over here, just on storage acquisition costs, is about $15,000 with about 3.6 terabytes of total raw capacity. You've got the same capacity over here, but now you're throwing in DAS controllers to do a lot of the same thing that the SANs do, because you could share it. You've got high availability. You could address a failover at the node. So you're actually spending quite a bit less in just storage acquisition costs. I mean, there's a lot of other serviceability and OpEx costs that aren't included in this that are also big cost savings. And you can see the level, you cut your cost per gigabyte down in half. You could also look at cost per I/O, or your OpEx costs. There's a lot of different ways to look at this and really abstract a tremendous amount of TCO savings. So the vision of the cloud storage is commodity servers or open servers as cloud storage appliances. So there's value-added software you could add to that. There's ways to introduce SSDs into this to get very great cost per I/O and cost per gigabyte. So you just add servers with drives to increase capacity. Your management and orchestration of the management is provided by cloud operating systems. So you could think of Nexenta, or you could think of KVM and Zen, and all kinds of open system virtualization environments where you're able to get very efficient, very open layers of virtualization. Again, automatic volume management. So think of VAST as a great example of an open systems volume management architecture. And advanced data services like data movement, replication, and migration. Again, there's great open system architectures that allow for this type of mobility. But you want 100% uptime. These things can never go down. It's not 5 nines. When you're talking about the cloud, you're talking about millions of users and the ability to scale from tens of thousands of servers. So there's a lot of advanced data servers that are required to meet those types of uptime. So the key takeaways is external storage was the obvious data center solution. SAN was the way to address the data center. Today, with shared DAS, you could do that with SaaS Fabric and get those same levels of service down at the block level, and then solve your uptime requirements with middleware. DAS virtualization meets the needs of the clouds. So again, you don't want to have disparate pools of storage. You want to virtualize storage. You can meet those requirements with DAS. And there's all kinds of exciting possibilities and innovation happening. We're at the forefront of the cloud. I mean, the public cloud is growing. You've got football fields of data centers full of DAS bricks. So there's all kinds of opportunities for us. It's a great time to be involved with storage, as it has been for the past 25 years. And I think that's our look from 25,000 feet. So please don't unbuckle your seats until we're at the gate. Thanks.